if you were away on October 7th, this is the things that we covered in class. So we went over logarithms and what logarithmic functions were. And previously we actually kind of learned about it, but we were all still confused about it, but now we learned it more into detail. So basically, what logarithmic functions is it's the inverse of exponential functions. And basically what logarithms are is basically what the value of the exponent value of a equation. So here you can see 2 to the power of x is equal to 32. You can actually use logarithms to solve for what x is. And I'll keep explaining for it to make more sense. So what are logarithms? Like I said again, logarithm is the value of the exponent. So for example, 2 to the power of 3 is equal to 8. So in this case, 3 would actually be the answer to the log equation. So basically what it's asking, or what log equations ask, and this is just in this example, like 2 to the power of what is equal to 8. And then the answer is that exponent. And it's written as log to the base of 2, and then 8, which is the answer, and then it's equal to the exponent. And if you want to put it into your calculator, you take your answer, log of the answer, and you of the answer of that base to the exponent, and you divide it by that base, log of the base. And you can try log 8 divided by log 2, and you should get 3, and because 2 to the power of 3 is equal to 8. And another thing that you should know is that log has a common base of 10, so log of 10 is just equal to 1. So whenever you have a number that is has a base of 10, you can just write that the value that the exponent and the base would give you. So for example, log 100 is the same thing as writing log 10. So basically asking like what 10 to the power of what is equal to 100, you can just write log 100. And then here, this is also specifically what we were given or shown in class. Log base n is equal to a. So basically it means that the base to the power of a is equal to n, and usually you're solving for the exponent, which is a. And b cannot equal 0, because we know that anything 0 to the power of anything is just 0, and if it equals to 1, 1 to the power of anything is just 1. Okay, and then we're going to do a lot of examples of these logarithms. We're going to start simple and go on to harder ones, but basically we have to follow BEDMAS and exponent laws, and all the way back to grade 9 to grade 11, these are the exponent root laws. You should just review them. Okay, so logarithmic functions, you can add on to solving for logarithms. Algebraically, logarithmic functions is finding the equation specifically. Instead of actually solving, you're isolating for a variable, and so it's good to have like a fundamental understanding of logarithms and how to actually solve them, so that you can actually be able to like isolate for the variable and simplify them. And I'll go over the example, some examples right now. If you missed class on October 7th, this is a video that will help go over the concepts that we learned in class, and this specific page is just examples that I took out of the homework, the questions that I think best helps to describe and go over easy to hard questions. And this is algebra with logarithms. So like I explained in the slides, I'm going to explain it one more time on how and what logarithms is. So here, what this is saying or asking is 5 to the power of what equals to 125? Right, and we probably know that it's going to be 3, but if you didn't know, like, what would you do? Or, like, what would you plug into your calculator? For your calculator, what you have to do is you have to plug in log, and then you take this number, which is the answer to your number, which is the answer to the base to the exponent of whatever. So you take log 125 and you divide it by the base, so log of 5. And if you plug that into your calculator, you should get 3. And we do. And basically that proves that 5 to the power of 3 is equal to 125. And we check, and there we go. That was a very simple question, and hopefully that made sense. We can try this harder one, and you have to follow BEDMAS, especially when we get to like these type of questions. Okay, so here, just a quick tip that I learned is when you have 13 as the base and also as a number to the power something, they cancel out, and you can just set it equal to 4, but I will do it the full way. So it would be log whatever this 13 to 4, so 13 to the power of 4 because you have to follow BEDMAS. So this is the same thing, log 13 28561, and then when you put it into your calculator, what you're going to plug in is log 28561 over log of 13, and you should get 4 log 28561 divided by log 13. Yep. Okay, this next one, and I guess I can actually prove like what I mean. So 13 to the power of 4 should give you this, and you can obviously we can see 13 to the power of 4 is equal to 13 to the power of 4. Don't need to do any math, you can see it. Here we have to take the 4th root of 27, which I'm pretty sure is a decimal. Yeah. So in this scenario, like I just use this number and I plug it in with log all at once on my calculator. So log and then this number, so 4 of 27 divided by log of 3. So 4 4 root 7, and then we take log of this answer and you divide it by log of 3, and we get 0.75, which is the same thing as 3 over 4. So basically what this means is 3 to the power of 3 over 4 is going to be equal to this, and we can check. 3 to the power of 3 divided by 4. So we get 2.279, blah, blah, blah. I think that's what we got before, too. 4 root of 27, 2.279, yeah. So that confirms that we are right. Next one, again, followed BEDMAS, so we have to do brackets first. We know that this is equal to 5, so log. Again, you can use that tip that I taught, so 5 and 5 should equal to 7. But we can again check. So log 5 to the power of 7 is equal to that. So 7, 8, 1, 2, 5 over log 5 is equal to 7. Again, just proving 5 to the power of 7 is equal to 5 to the power of 7. Okay, and then 2 more examples. So when you have this in the exponent, we have to do BEDMAS again. So do the exponent first, then after we're done that, we do the subtraction. So here, I like to just separate it. So it's going, this is 4 to the power of whatever the log is. So it's going to be, I'm just going to plug it in as if I'm plugging into my calculator. So log 39 over log 4 minus, and it does look intimidating, but it's not, log 23 over log 7. So log 39 divided by log 4, and then it's a decimal number, but it's 4 to the power of that number. So there we go. Now we get a whole number, less scary. And then we have log 23 divided by log 7, and this is 7 to the power of that, which we get 23. It's funny how this and this actually cancel, and it ends up being 39 minus 23, which is 16. Well, 16. Okay, and then finally, our last example. So here, we can, so it would be log and 6 to the power of 3, 216, so log 216 divided by log of 1 over 36 plus, this one's going to be simple, log of 64 over log of 2. So make sure to plug it in your calculator properly. So log 1 divided by 36, and then log 216 divided by this answer. So log we get negative 1.5 log 64 divided by log 2 is 6. And we should get 4.5. And this is how you would solve for logarithms. You just have to follow exponent rules, BEDMAS, and also the new concept of logarithms. Okay, and then now I just want to go over to, this is a previous lesson that we did in class, and I want to go back to this question. We were lost this one day, and now that we figured it out, we can actually go back and see like what we did wrong or what we did right. So this is the equation that we did. We're going to do it separately, and I will explain how to actually derive the inverse equation now that we know how to use logarithms. Okay, so we have to get rid of this 1.5, so divide by 1.5. And then now we can take the log of 3 on both sides, so it's going to be x over 10, and then we can multiply both sides by 10. There we go. And then now that we have this equation, which is the same thing we got before, but we don't really understand why and how we got it, we can actually plug in a value and see if it's the right one. If we got the right equation. If we look back here, we had these exact points. We can use this to verify our answer. So, for example, if I put in a 4.5 for the y, let's see what it actually gives us. Alright, so if I put in a 4.5, so the way I would plug that into my calculator would be like this. So 10 multiplied by log, and then I think it was 4.5 over 1.5 over log of 3, and this would give us an x, and it should give us 10, but let's see. So log of 4.5 divided by 1.5 divided by log of 3 times 10, which is 10, which is amazing. So this would be our final inverse function, and that's how you would isolate for inverse or logarithms.